Hello friends, welcome to my lecture on applications of Z transforms. We have seen that the Z transform of the sequence un equal to 1 is Z over Z minus 1 when mod of Z is greater than 1, and the Z transform of the sequence un equal to n is Z over Z minus 1 whole square when mod of Z is greater than 1, and Z transform of the sequence un equal to n square is Z square plus Z over Z minus 1 whole cube when mod of Z is greater than 1. Now, we can also find the Z transform of the sequence un equal to n cube by using the recurrence relation Z transform of n to the power p, Z transform of the sequence n to the power p equal to minus Z d over dz of Z transform of n to the power p minus 1, where p is a positive integer. So, here Z transform of n cube, where we have taken n equal to 3 here. So, Z transform of n cube is minus Z d over dz of Z transform of n square. So, we write the Z transform of n square, that is Z square plus Z over Z minus 1 cube here, and then differentiate with respect to Z and multiply by Z. We arrive at Z cube plus 4Z square plus Z over Z minus 1 to the power 4 when mod of Z is greater than 1. This Z transform we will need when we solve difference equations. So, we had to derive this Z transform of n cube. Now, let us what I have done is that we are taking Z transforms, inverse Z transform of some special functions, where we shall see that when we write the partial fractions of uz over z, we have to write uz over z, the partial fractions of uz over z according to the inversion formulas. That is, we will have to use, while inverting, we will have to use the Z transforms of special sequences. So, we will have to write in the uz over z also in that form. So, for example, here when we say Z inverse of Z cube over 20Z over Z minus 2 whole cube equal into Z minus 4, let us see how we write the uz by z into partial fractions. So, what we do is, let us say, let uz equal to Z cube minus 20Z divided by Z minus 2 whole cube into Z minus 4, then uz by z. By in the partial fractions method, we have to write uz by z into partial fractions. So, we write a over Z minus 4, b over Z minus 2, c over Z minus 2 whole square. See, we have Z minus 4 power 1. So, we will have one partial fraction corresponding to the factor Z minus 4, but corresponding to Z minus 2 whole cube we will have 3 fractions, one with Z minus 2, with the other one with Z minus 2 whole square, and the third one with Z minus 2 whole cube. Now, let us see how we will have to write these partial fractions. While inverting, we will write uz will be a times Z over Z minus 4. So, while inverting, the inverse Z transform of Z over Z minus 4 will be 4 to the power n. So, we will be able to invert, and here we will get Z over Z minus 2, inverse Z transform of Z over Z minus 2 will be 2 to the power n. So, that is also possible to invert, and here we will have Z over Z minus 2 whole square. Let us recall that Z transform of n into a to the power n is az upon Z minus a whole square when mod of z is greater than mod of a. So, here if you take, because here I have Z minus 2 whole square, so you take a equal to 2. So, Z transform of n into 2 to the power n will be equal to 2Z upon Z minus 2 whole square, and so we can say that Z transform of n 2 to the power n divided by 2 will be Z upon Z minus 2 whole square. So, inverse Z transform of Z over Z minus 2 whole square will be n times 2 to the power n by 2. So, we will be able to invert this term also, Z over Z minus 2 whole square, but here when we come to Z minus 2 whole cube, let us recall the formula for n square a to the power n. We have Z transform of n square a to the power n. This is equal to a z square plus a square z divided by z minus a whole cube. So, this is actually z times az plus a square divided by z minus a whole cube. Now, if I take a equal to 2, taking a equal to 2 we get z transform of n square into 2 to the power n equal to z into 2z plus 4 divided by z minus 2 whole cube. So, z while writing uz, this z we will get come here. So, we have that z here and then 2z plus 4 also is needed. So, what we do is we write here d times 2z plus 4. Now when we will be able when we will find the values of a, b, c and d, this term we can also invert, because this term will be z into 2z plus 4 divided by z minus 2 whole cube. So, its inverse z transform will be n square into 2 to the power n. Now, the only thing that remains is to do here is that we have to find the values of a, b, c, d. So, a can be found easily. A corresponds to z square minus 20, because uz by z is z square minus 20 divided by z minus 2 whole cube, z minus 2 whole cube. So, this is when you put z equal to 4. So, you put z equal to 4. So, we get 16 minus 20 divided by 4 minus 2, that is 2 whole cube. So, that is 8, and we get here minus 4 by 8. So, we get minus half. We can then write, this is let me say that we write it as z square minus 20 divided by z minus 2 whole cube into z minus 4. So, equating both sides, we can also find the value of d directly. What you do is, let us write from this equality we write z square minus 20 equal to a times z minus 2 whole cube plus b times z minus 2 whole square into z minus 4 plus c times z minus 2 into z minus 4 and d times 2z plus 4 into z minus 4. Now, you can see that when you take z equal to 2, this term is 0, this term is 0, this term is 0 and this term is non-zero. So, we will get the value of d. So, putting z equal to 2, we have 2 square means 4 minus 20. So, we get minus 16 equal to d times 2 into 2, that is 4, 4 plus 4 is 8, and then we get 2 minus 4, that is minus 2. So, minus 16 d equal to minus 16, this gives you d equal to 1. And the next thing that we can do is let us equate the coefficients of various powers of z. So, equating the coefficient of z cube on both sides. Here we have term in z cube 0. So, the coefficient of z cube is 0 there. Here the coefficient of z cube is a plus b. So, equating the coefficient of z cube both sides, we get a plus b equal to 0. Now, a we have already found, a is equal to minus half. So, b is equal to half. Then we can equate the constants on both sides, which means that we can put z equal to 0 in this equation. So, putting z equal to 0, we get let me call this equation as equation number 1. So, putting z equal to 0 in 1, what we get is I will write here. So, minus 20 equal to a times minus 2 whole cube. So, minus 8 into a, and then we get minus 2 whole square, which is 4. 4 into minus 4, that is minus 16. So, minus 16b, and then we will get c times minus 2 and minus 4. So, that is 8 times c, and here we shall have z equal to 0 means d times 4 into minus 4. So, minus 16d. Let us use the values of a, b, c, a, d, b and d. So, a is equal to minus half. So, minus 8 into minus half, and then we will have the value of d, b equal to half, and then we have to find the value of c, minus 16, d is equal to 1. So, how much is this? R minus 20 equal to this is 4, 8 by 2 is 4, here we get minus 8, here we get 8c minus 16. So, this is 4 minus 24, that is minus 20. So, c is equal to 0. Now, so we get c equal to 0, and thus we have the following fractions. So, hence uz by z, a is equal to minus half. So, minus 1 by 2 1 over z minus 4, then we have v equal to half. So, we get 1 by 2 z minus 2, and c is 0, d is 1. So, we get 2z plus 4 divided by z minus 2 whole cube. Now, let us multiply by z. So, r u z equal to minus half z over z minus 4 plus half z over z minus 2, and then 2z square plus 4z divided by z minus 2 whole cube. Now, let us take inverse z transform both sides. So, taking inverse z transform, we get un equal to minus 1 by 2 4 to the power n, then 1 by 2 2 to the power n, and this is n square into 2 to the power n. And for these transforms, okay, mod of z is greater than 2, but here mod of z is greater than 4. So, we will take mod of z greater than for the common region. So, this is the inverse z transform of z cube minus 20z over z minus 2 to the power 3 over z minus 4. So, while writing the partial fractions of uz by z, we have to write them in such a way that while inverting we get the standard sequences. So, standard results we will have to use. Now, the again next in the next example, we have taken this difference equation, and we have to find the response of the system, that is we have to find the sequence yn such that by naught equal to 0, by 1 equal to 1, and here we are given that un is equal to unit step sequence, un equal to 1 for n equal to 0, 1, 2, 3 and so on, and which is nothing but the unit step sequence. And for the unit step sequence, if you remember, we have seen that the z transform is z over z minus 1, where mod of z is greater than 1. So, here we shall see that the sequence by n is equal to 1 by 2 minus 2 times 2 to the power n plus 3 by 2 3 to the power n. Let us see how we get the solution of this. It is very simple difference equation. So, as usual, let us take the z transform of the given difference equation by n plus z transform of by n plus 2, and then we have minus 5 times z transform of by n plus 1, then we have 6 times z transform of the sequence by n equal to z 6 times z transform of the sequence by n, and then we have z transform of the unit step sequence un. Z transform by n plus 2 we can find by the shifting property. This is Z square times by Z, where by Z is the Z transform of the sequence by n minus by naught minus by 1 by Z minus 5 times Z of by n plus 1 is Z times by Z minus by naught plus 6 times Z transform by n we have taken as by Z equal to unit Z transform of the unit step sequence is Z over Z minus 1. So, here we have taken mod of Z greater than 1. Now, let us use the values of y naught and y 1. Y naught is 0, y 1 is 1. So, Z square times by Z minus 1 by Z, because y naught is 0, y 1 is 1, minus 5 times Z into by Z, because y naught is 0, plus 6 by Z equal to Z over Z minus 1. This is how much? Let us collect the coefficient of yz here. So, Z square minus 5Z plus 6 times by Z equal to Z over Z minus 1 plus Z, which is Z square divided by Z minus 1. Now, the factors here are Z minus 2 and Z minus 3. So, we can write by Z equal to Z square divided by Z minus 1, Z minus 2, Z minus 3. Okay. So, as usual, let us write by Z by Z. So, then by Z will be Z over Z minus 1, Z minus 2, Z minus 3, which we shall write as A over Z minus 1, because Z minus 1, Z minus 2, Z minus 3 all occur in power 1. So, for each one we will have one fraction. So, B over Z minus 2, C over Z minus 3, and we can see that while writing by Z, each term here will be multiplied by Z. So, and we will be able to determine the inverse Z transform of Z over Z minus 1, Z over Z minus 2, Z over Z minus 3, and so we just have to find values of ABC. So, A, you can see A is equal to Z over Z minus 2, Z minus 3 at Z equal to 1, which comes out to be 1 over 1 minus 2, 1 minus 3. So, this is minus 2, this is minus 1. So, we have 1 over 2, and similarly B will be Z over Z minus 1, Z minus 3 at Z equal to 2. So, we get 2 over 2 minus 1 is 1, 2 minus 3 is minus 1. So, we get minus 2. And then C similarly will be Z over Z minus 1, Z minus 2 evaluated at Z equal to 3. So, we shall have 3 over 3 minus 1 is 2, 3 minus 2 is 1. So, we get 3 by 2, and thus by Z will be equal to, let us multiply by Z, the value of A we have found as half. So, half Z over Z minus 1, the value of B we have found to be minus 2. So, minus 2 times Z over Z minus 2, and then the value of C we have found 3 by 2. So, 3 by 2 Z over Z minus 3. So, inverse Z transform of by Z, which will be equal to the sequence by n. This is equal to half 1 to the power n minus 2 times 2 to the power n, and then we get 3 by 2, 3 to the power n. For this mod of Z is greater than 3, for this mod of Z is greater than 2, and for this mod of Z is greater than 1. So, we have mod of Z greater than 3, which is the common portion. So, the inverse Z transform is half minus 2 into 2 to the power n plus 3 by 2 into 3 to the power n. Now, let us go to this problem where we shall see that we have to use the Z transform of n cube, which we have found earlier. Okay, so let us consider the difference equation un plus 2 minus 2 un plus 1 2 un plus 1 plus un equal to 3n plus 5. You can see that here we are not given any conditions on the sequence u1. So, the u0 and u1 u2 which will occur while taking the jet transform of this will be taken as some arbitrary constants. We will see that there will occur u0 and u1. So, u0 and u1 will be taken as some constants, and while writing the solution of this problem, we shall see that we have to choose C0 as u0 and C1 as u1 minus u0 to arrive at this sequence, the solution of the problem. So, let us take jet transform of this. So, taking jet transform on both sides, we get okay. So, jet transform will be equal to z square uz minus u0 minus u1 by z, and then minus 2 times z into uz minus u0, the z transform of un plus 1, plus z transform of un will be uz 3 times z transform of n. Let us recall that z transform of n is equal to z over z minus 1 whole square, where mod of z is greater than 1. So, this is z over z minus 1 whole square, and z transform of 5 is a constant. So, we need to know the z transform of 1. Z transform of a to the power n was equal to z over z minus a, provided mod of z is greater than a. So, taking a equal to 1 here, we have z transform of 1 is equal to z over z minus 1. So, provided mod of z is greater than 1. So, this is z over z minus 1 provided mod of z is greater than 1 for these to be true. Okay, so, now let us take the coefficient of uz. So, z square minus 2z plus 1 into uz, and here we shall have minus u0 into z square, here we shall have u1z, and here we will get 2 u0z equal to 3 times z over z minus 1 whole square plus 5 times z over z minus 1. Okay, so, let us collect, let us now find the value of uz. So, uz will be equal to, okay, so uz will be equal to, this is z minus 1 whole square. So, let me write it as z minus 1 whole square into uz, and let us take these terms to the other side. We have 3 z over z minus 1 whole square plus 5 times z over z minus 1, and then we have here u0 times z square minus 2z, u0 times these terms when go to the other side will give you u0 times z square minus 2z plus u1z. Let us divide by z minus 1 whole square to get uz. So, uz is equal to 3 z over z minus 1 to the power 4 plus 5 z over z minus 1 to the power 3, then u0 times z minus square minus 2z divided by z minus 1 whole square, and then u1 z over z minus 1 whole square. Now, let us write uz by z from here, and then we shall write the fractions of uz by z in such a way that we can easily get the inverse z transform. So, uz by z is equal to 3 by z minus 1 to the power 4, 5 upon z minus 1 whole cube, and then we have here u naught into z minus 2 divided by z minus 1 square. Then we have u1 upon z minus 1 whole square. Now we can see that in the denominator we have z minus 1 power of z minus 1 as 2, 3, 4. So when we write the partial fractions corresponding to this uz by z, we have to write 4 fractions corresponding to z minus 1 to the power 4. So this we shall write as a over z minus 1, b over z minus 2. Sorry, a over z minus 2 1, b over z minus 1 square. Now so far when you will write uz, you will multiply this by a and term in a and b by z. So z over z minus 1 can be inverted, z over z minus 1 whole square can also be inverted, but here when you will multiply by z, the term corresponding to z minus 1 to the power 3. So let us recall that z transform of n square a to the power n, this was equal to a z square plus a square z divided by z minus a to the power 3. So corresponding to z minus 1 cube, we will have to have in the numerator a term like this. So what we will do, let us take a equal to 1. So z of n square will, by taking a equal to 1, is how much, z square plus z divided by z minus 1 whole cube. Z minus 1 whole cube. So we will so this z is to be multiplied to z plus 1 in order to get z square plus 1. So we get here c times z plus 1. So that when we multiply by z, we get c times z square plus z divided by z minus 1 whole cube, whose inverse z transform will be n square into a to the power n, but a is equal to 1, so n square. So this is how much we, this is how we write the term corresponding to z minus 1 whole cube. Then the term corresponding to z minus 1 to the power 4 we have to write. Now let us recall the z transform of n cube which we had found earlier. So this is what we have. So corresponding to z minus 1 to the power 4, in the numerator we must have z cube plus 4z square plus z. One z will come from uz by z, so we need to have z square plus 4z plus 1. So we write here d times z square plus 4z plus 1. So this is how we will write uz by z, and now our aim will be to find out the values of a, b, c, d. So which we can do easily. So we shall write so this is uz by z. uz by z is equal to let me, I think I have omitted that. Okay. So this is equal to a times z minus 1 to the power 3 plus b times z minus 1 to the power 2 plus c times z plus 1 into z minus 1, and then we have d times z square plus 4z plus 1. Now uz was equal to now uz by z, we have seen uz by z is equal to 3 over z minus 1 to the power 4, and then we have 5 over z minus 1 cube, and then we have u naught times z minus 2 upon z minus 1 to the power 2 plus u1 upon z minus 1 whole square. So this is uz by z is equal to this. So let us equate both the sides. This is divided by z minus 1 to the power 4. Here also we can write z minus 1 to the power 4. So this is z minus 1 to the power 4 So, 3 plus 5 times z minus 1 plus u naught times z minus 2 into z minus 1 whole square plus u1 times z minus 1 whole square. So, this way this is equal to this. So, we have a times z minus 1 whole cube plus b times z minus 1 whole square plus c times z plus 1 into z minus 1 plus d times this equal to the numerator here. So, then plus this will be equal to u1 times z minus 1 whole square. Now, from here if when we solve this we can get the value, we get the from the equations that we get we shall be able to determine the values of a, b, c, d. Let us see if we put okay, we can easily see that a is equal to u naught. How we get a is equal to u naught here? By taking z equal to if we okay z cube, the term in z cube. Okay. So, here we see that okay, let us go equate the coefficient of z cube both sides. So, equating here the coefficient of z cube is a, here the coefficient of z cube is u naught. So, we get a equal to u naught, and we will similarly we can equate the coefficient of z square, the coefficient of z, the constants, we will get the equations, and then we can see that a comes out to be u naught, b comes out to be u1 minus u naught minus 3 by 2, and c comes out to be equal to 1, d is equal to half. So, a is equal to u naught, b is equal to u1 minus u naught minus 3 by 2, c is equal to 1, d is equal to half. So, we put these values here and then take the inverse Z transform. So, we shall have, so using these values of a, b, c, d, we then get uz equal to a times z over z minus 1. So, u naught times z over z minus 1, and then b is u1 minus u naught minus 3 by 2 into z over z minus 1 whole square, and we will get c is equal to 1. So, z plus 1, so z square plus z divided by z minus 1 whole cube, and then we will get d times d is equal to half. So, d equal to half will give us 1 by 2 times z cube plus 4 z square plus z divided by z minus 1 to the power 4. Now, take the inverse Z transform. So, Z inverse u z which is equal to u1 sequence will be equal to u naught into 1 to the power n, u1 minus u naught minus 3 by 2, and then we get here Z transform of n into a to the power n is a z over z minus a whole square. So, taking inverse Z transform, take n a equal to 1 and then take the inverse Z transform, the inverse Z transform of z over z minus 1 whole square will be n. So, we get n here, then we get here Z transform of n square. So, this is Z transform of n square. So, we get n square here, and then we get half of n cube. So, if we simplify this we will get u n equal to c naught plus c 1 n plus half of n into n minus 1 n plus 3. We can easily check that, where we have chosen C naught equal to u naught and C 1 equal to u 1 minus u naught. So, this is how we will find the solution of the difference equation given in example 3. I think with those examples, the how to deal with the solution of a difference equation must be very clear to you. Thank you very much for your attention.